Welcome. This is your teacher David Garcia, and today we will be working with the topic system of equations. The objective for today's topic is to solve a system of equations, particularly two equations with two variables, through the method of elimination. There are different methods, but we will focus today only on this one. Now, in order for us to understand what we're doing, let's take a look at this. The equations that we will be working with will be linear equations. That means that each equation is representing a line in here. And we have two lines, the blue line and the red line. Now, we know that there are many different ways in which these lines, there's actually an infinite number of ways in which these lines can be, let's say, arranged on a Cartesian plane. So for example, if I start playing with the intersection value for the blue line, I can see that my blue line is going up and down as I am changing this number. Let's leave it in here in -2. And the red line, right, if I start playing with it, right, with the intercept value, it will start doing the same, going up and down. Let's leave it in here in +1. And now, if we take a look at the slopes for both lines, we will see that both slopes are equal to 1. So that means that they are parallel. The moment that I start changing these slopes, I will generate an intersection point. And that intersection point will actually be the solution for these two lines, or the system of equations of these two lines. So it won't matter, right, how these lines are in our Cartesian plane, all right, where they are. As long as they have an intersection point, there will be a solution for the system. Again, the solution will be that point. But what happens when those two lines have exactly the same slope, like in this case? It doesn't matter, right, where they are located or where they are intersecting the y-axis. These two lines will never touch. They are parallel. They will never cross each other out. And therefore, there will not be a solution for this problem. And we have the last case. If these two lines not only share the same slope, but they intersect the y-axis on the same point, then if you see, we cannot distinguish one line from the other. That means that every single point on both lines is an intersection point. Therefore, there is an infinite number of possible solutions for this case. So let's go back and let's take a look at how this will go down. So let's begin with example number 1. Let's imagine that we are given these equations. -1 minus 11y equals -8x. And the other equation is 0 equals 165 minus 60x plus 51y. Now, it doesn't matter how the equations are written. What we will try to do is to arrange them in such a way that we have the variables, right? The y and the x on one side and the numbers on the other. So let's begin by working with this. For the first equation, we're going to take this negative 11y and we're going to move it to the other side. It's subtracting, so it will go adding. So we will have negative 1 equals negative 8x plus 11y. So let's rewrite it. I'm going to move the variables onto the left side and the numbers to the right side. There we go. So if you see, now I have the variables on this side and the numbers on the right side of the equality. So now I'm going to do the same thing for the other equation. I'm going to move this number, the 165, to the other side. So I will have negative 165 equals negative 60x plus 51. So now I can take this second equation and organize it in this way. So we'll have negative 60x plus 51y equals negative 165. So I'm going to take this equation right here, and I am going to put it down here. Now, my objective is to add these two equations and add them in such a way that one of the variables will be eliminated. This is the idea behind the elimination method between them. So it seems in here that the easy way to go is to modify this number right here so that we can make it equal to 60, but with opposite sign. So if I take my calculator and divide 60 by 8, let's do that. I have 7.5, which is the same as 15 halves. So I am going to multiply this equation right here by 15 halves. And I'm going to write my new equation down here. Now, one of the things that you have to be careful for are the signs. If I don't change the sign in here, I won't be able to cancel this number. So let me put it right here, negative. So now it is negative, let's put these numbers in the calculator, negative 15 halves times negative 8 will be 60x. And then negative 15 halves times positive 11, it will be negative 165 halves of y. This will be equal to negative 15 halves times negative 1 will be positive 15 halves. And now I can do the addition of these two equations. If you see, the negative 60x and the positive 60x will cancel each other out. It'll be a 0. And then I have 51y minus 165 halves of y. Again, I put 51 in my calculator minus 165 y's. And these will be negative 63 halves of y. This will be equal to negative 165 plus 15 halves. Have negative 315 divided by 2. Now, a little trick in here. Whenever you have an equality, and on both sides of the equality, you have fractions, and those fractions are sharing the same denominator, you can get rid of that denominator by multiplying everything times that number. In this case, it's 2. So by multiplying times 2, sorry about that. By multiplying times 2, I get rid of this, and now I end up with an easier equation. That is negative 63 equals to negative 315. This negative 63 is multiplying, so it will go to the other side, dividing. So y will be equal to negative 315 divided by negative 63. Put this in my calculator, and I get that y equals 5. So what I have gotten so far is the y coordinate of the intersection point. So now it's just a matter of selecting one of the original equations, the one you like the most, to substitute this number 5 in here and come up with the value for the x variable. Now, I think I'm going to use this one, right, since it has smaller numbers. So negative 1 minus 11y equals negative 8x. Is 8. This negative 8 is multiplying. It's going to go to the other side, dividing. So I have negative 1 minus 11y, and everything will be divided by negative 8 will equal x. So let me just do a little rewriting. There we go. So now I can substitute my 5, the value for the y coordinate in here, and I will be done. Negative 1 minus 11 times 5, and everything divided by negative 8. I put these values in my calculator, and I get that x equals 8. And that's it. This is how you calculate the solution for a system of 2 equations with 2 variables by the method of elimination. Remember that these 2 coordinates, another way of understanding them, or these 2 values are the coordinates, 5, for the point of the intersection of both lines. The point that would be the solution would have these coordinates. Now, in this first example, we have a solution. Now, what happens when you don't have a solution? Okay, let's see another example in here. So let's imagine that we are given, there we go, negative x minus 7/88, and this is equal to 7/11y. And the second equation they give us is 196y equals 28 minus 308x. The idea is very much the same. So let's begin by rearranging our first equation. And let me move this variable to this side over here. So if it's adding, it will go subtracting. And this one, I will move it to the other side. If you see, it is subtracting, so it will go to the other side, positive. So I have negative x minus 7/11y equals 7/88. Now, in my second equation, I'm going to take the negative 308, and I'm going to move it to the other side, adding. So I will have 308x plus 196y equals to 28. So let me get this equation right here. And now I have both of my equations ready. Now this one is easy because if I want to get rid of this variable, I just have to multiply this equation times 308. No problem there. So let's do that. Let's multiply this whole equation times 308. And let me put the new equation right here. So I will end up with negative 308x. Then let's put these numbers in the calculator. 308 times negative 7/11, again, negative 196y. And this will be equal to now 308 times 7, and then divided by 88, 28. That was a previous number, 49 halves. So now I can add my equations. But if you see the 308x, or in this case, the variable x will get canceled, but also the variable y will get canceled. So I end up in here with a 0, and this will be equal, let me do 28 plus 49 halves. I have 105 halves. What is this, right? If this is an equality, all right, this is wrong. 0 cannot be equal to a different number than 0. So whenever this happens to you, whenever you find an equality in which the variable side end up with a number and the number side with a different number, right, therefore not respecting the equality, this system of equations will not have a solution. Why? Because what we're looking at is at two parallel lines. So in this case, the blue line, the black line would be parallel. Now, for the final case, we have seen a case that has a solution. We have seen a case that doesn't have a solution. And now let's see an example in which there will be an infinite number of solutions. So in this example, we have 32 equals 16x plus 288y. Our second equation is y equals 19 minus 1/18 of x. So let's begin. I am going to just rewrite this equation because if you see in this case, we already have the variables on one side and the numbers on the other. So let's just rewrite it. We have 16x plus 288y equals 32. Now, in the second equation, I will just have to move this x that is subtracting to the other side. So let me write it here. I will have 1/18x plus y equals 1/9. Now, in this example, the easy way to go will be to modify this y. Right? We have 288 in here. It is positive. So that means that I have to multiply this whole equation times negative 288. So this negative 288 times 1 divided by 18 will be negative 16x minus 288y, and this will be equal to now 288 negative times 1 divided by 9 will be 32 negative. Now, if I add both of my equations, it becomes very obvious what will happen. The x variable gets canceled, the y variable gets canceled, and then the numbers get canceled as well. So you end up with 0 equals 0. Now, this equality stands true, right? And the interpretation is that there is an infinite number of solutions. Why? Because they are exactly the same line. And that's it. These are the 3 possible cases that you will find when solving systems of equations. Thank you very much, and I will see you in our next session.